The objective of the composition lab was to determine the concentrations of unknown NaCl and food dye in water using a system mass balance. We weren't allowed to test the unknown directly, so to begin we must set up several calibration curves. The first we set up was a conductivity curve. We created this by testing the conductivity of water with different amounts of NaCl to create a graph relating the conductivity and the concentration. The conductivity meter was quite random sometimes, and the values in the center of our graph aren't great, and we believe that this will account for some error we find later. Next, we need to find a curve for the absorbance. We did this by measuring the absorbance of different concentrations of food dye in water and then graphing them absorbance versus concentration. Our data for this part of the lab is much better, with an R-squared of about 0.999. The next image is of the setup we used to find our unknown concentrations. I used trial 1 as the basic calculations to show here as an example. From here, we would find the concentration of the mix, and then we would use the mass balance or the material balances to calculate a weight and volume percent for conductivity and absorbance respectively. This next part shows us taking our conductivity test. This is testing our unknown, and it's important for us to wait until the system gets to steady state to take our data, which was timing how long it took to fill 1 liter. After this, we would then test the conductivity to get our final data. This part shows us taking our spectrophotometry test, and again, it's important to wait till the system gets to steady state. And this time we only measured the time it took to get to 1/2 liter because we had much less of the food dye unknown than we did the NaCl unknown. We would then test the absorbance of the mix to get our final data. In the end, for our conductivity data, we got an average weight percent of 1.169% of the total mass was NaCl. The actual was 2.5%, which is not inside our confidence interval, and our percent error is about 53.2. We believe that our error was so high because of the conductivity meter having a tendency to be quite sporadic at times. For the absorbance data, we got an average volume percent of 0.0724% of the total volume was food dye. The actual volume percent was about 0.05%, which is inside of our confidence interval, and that gives us a percent error of about 44.8. We also believe that some of our error can be attributed to the fact that we didn't take incredibly precise measurements when we were measuring the flow rates, only using a timer and eyeing how far the flow had proceeded.